Hello, my name is Zach Chandler, and I'm here today to show you how to use a PhET wave on a string simulation to improve student understanding of how waves work in the classroom. And at the same time, I'm here to show you how this PhET simulation tech tool falls within the TPACK model. Now, what you can notice right away is there's a variety of buttons here. You can change the amplitude. Students can adjust the amplitude from 0 to 1.25. They can change the frequency, that's how many waves are made per second. They can adjust and change the dampening to see how much, the amount of dampening, or we could say friction, affects the speed of wave or wave properties. We can change the tension to see how tension affects the speed of wave or wave properties. We can also change the ends. Notice right now we have this cool window, so the wave's just going to continuate out of it, kind of like an antenna sending out a wave pulse. Or I could have a loose end, so the wave's going to come down, but it's free to move out this end, but it will reflect back. Or I could have a fixed end where the end's clamped down, and it will send the wave back. So students are able to freely explore within this tech tool, and we can have them to see if you change the amplitude, what's the outcome? If you change the frequency, what's the outcome perhaps of the wavelength, the speed of the wave? What if I add more dampening? What do we observe? If I increase the tension? Now, if I want students to make exact measurements, I can use this cool ruler tool, which is manipulable. I can use this cool timer tool, okay? And you can even add reference lines if you need it. So I could drag this and put it down here, but you can already see there's one there for you. So I'm going to take that off. And all this allows students the freedom to explore. Now, with a guided worksheet or guiding questions, students can be, guided to explore the relationship between amplitude and a physical quantity, frequency and physical quantity. All of this could be done in a lab. However, some teachers suffer from large class sizes, or some students don't want to participate in group activities and they'd rather learn independently. So using this gives students options. And this is where the good pedagogy comes in. We want students to explore and learn through exploration, but we also want all of them to be involved. And if students don't want to get involved with a physical hands-on lab, perhaps using this simulation one-on-one would be great. Content-wise, we want the students in physics to develop relationships between physical quantities such as amplitude and frequency, amplitude and speed, tension and speed, so on and so forth. So we can design this simulation to build those relationships or have the students uncover those relationships. And lastly, we want to invoke technology or use technology to weave together the content knowledge and the pedagogy we are using in our classroom. And this tool does that perfectly. Last thing I'm going to show you is an example. So perhaps I want my students to find the relationship between amplitude and wave speed. So I put it to wave pulse. I haven't put an end on here so the wave can keep going. And I could have the timer running or just observe. I'm going to send a wave pulse. And we can see that the wave goes. If I make the amplitude much bigger, students can see, is it quicker, slower, or the same amount of time for that wave to reach the window? And all they would need is this timer. And using these resources, and they could also put it into slow motion, using these resources, students can find out that there wouldn't be any change in the wave speed based off changing the amplitude.